question number 66, which says that calculate the change in entropy at 298 Kelvin for the reaction in which urea is formed from ammonia and carbon dioxide, and you have been given the standard entropy of all the species. So the entropy change of the reaction is equal to entropy change for the products minus entropy change for the reactant, and where NP and NR are the moles. So यहाँ पे अगर हम देखते हैं तो प्रोडक्ट में हमारे पास क्या है, यूरिया एंड वाटर. So यूरिया की स्टैंडर्ड एंट्रोपी वी हैव बीन गिवन, दैट इज 174. So it is 174 plus standard entropy for the water. For water we have been given, that is 75, and minus for ammonia. So now coefficient for ammonia is 2 into 195 minus for carbon dioxide. So it is 213.7. ठीक है. So if you calculate this, it will come out to be minus 354.7 joule per Kelvin per mole, as all the values are given in joule per Kelvin per mole. So option number 1 will be the correct answer. So moving on to the next one, we have question number 67, which says that at 25 degrees Celsius, if the concentration of Ag plus ion is 1.5 into 10 raised to the power minus 4 mole per liter in the saturated solution of Ag2CrO4, then solubility product of Ag2CrO4 is. So we have silver chromate, which will dissociate as 2Ag plus and CrO4 2 negative. ठीक है. So the Ag plus concentration will be here 2S, and for CrO4 minus it is S, where S is the solubility. And also the concentration of Ag plus you have been given, that is 1.5 into 10 raised to the power minus 4. So हम यहाँ से लिख सकते हैं concentration of Ag plus, which is equal to 2S, is equal to 1.5 into 10 raised to the power minus 4. ठीक है. So यहाँ से S की वैल्यू कितनी आ जाएगी, it will be equal to 1.5 into 10 raised to the power minus 4 divided by 2. So now you have to find out the solubility product, so which is KSP. So KSP का expression क्या होता है, it will be equal to concentration of Ag plus whole square, because the coefficient of Ag plus is 2 here, into concentration of CrO4 2 negative. Concentration of Ag plus, we know that that is 1.5 into 10 raised to the power minus 4, and for CrO4 minus it is 1.5 into 10 raised to the power minus 4 divided by 2. So if you solve this, it will come out to be 1.69 into 10 raised to the power minus 12. So option number 3 will be the correct answer. So moving on to the next one, we have question number 68. So among the following, which salt don't undergo hydrolysis? So the salts of strong acid and a strong base don't undergo hydrolysis, because neither the cation nor the anion undergo hydrolysis. So in the case for CH3CONa, we have a weak acid, that is CH3COH. So CH3COO minus will undergo hydrolysis. So this is wrong option. So now we have NaCN, which is composed of NaOH and HCN. So NaOH is a strong base, but HCN is a weak acid. So Cn minus will undergo hydrolysis. So this will not be our answer. Now we have sodium carbonate. So sodium carbonate is composed of sodium hydroxide and carbonic acid. So you know that carbonic acid is a very weak acid, so it will undergo hydrolysis. So this will not be our answer. Now we have sodium nitrate, which is composed of sodium hydroxide and nitric acid. So sodium hydroxide is a strong base and nitric acid is also a strong acid. So it will not undergo hydrolysis. So option number 4 will be the correct answer. So moving on to the next one. So we have question number 69, which says that if 2 degrees Celsius rise in temperature takes place on the combustion of 0.1 gram of methane gas in a bomb calorimeter and the heat capacity we have been given, that is 500 joule per degree Celsius at 27 degrees Celsius. Then the value of heat of combustion at constant pressure for 1 mole of methane gas is. So in the bomb calorimeter, heat is evolved at the constant volume. So we can say that it is delta U, because it is heat evolved at constant volume. So it is minus heat capacity of bomb calorimeter multiplied by rise in temperature multiplied by molar mass of the gas divided by weight of the gas. Fine. So heat capacity we have been given, that was 500, and the rising temperature is 2 degrees Celsius into molar mass of methane gas, that is 16, divided by weight of the gas, that is 0.1 gram. So it is equal to minus 160 into 10 raised to the power 3 joules. Fine. So now we have to find out the value of heat of combustion at constant pressure. Means we have to find the value of delta H. So delta H is equal to delta U plus delta Ng RT. Fine. So delta U की value we have already found out, but the value of delta Ng is still remaining. So now we have been given the combustion of methane gas. So we can easily write down the equation for the combustion of methane gas. So it is CH4 plus O2, which will give CO2 plus water. Fine. So CH4 is in the gaseous form, O2 is in the gaseous form, CO2 is in the gaseous form, and H2O at 27 degrees Celsius will remain in the liquid form. So now balance the chemical equation. So it is 2 water molecule and it is 2 oxygen molecule. So here delta Ng will be equal to 1 minus 3, which is minus 2. So now substitute the value here. So it is minus 160 into 10 raised to the power 3 minus 2 into 8.314 into temperature. Temperature 27 degrees Celsius. So convert this into Kelvin. So it will be equal to 300. So if you calculate this, you will find the value, that is 164,988 joules. So it is nearly equal to minus 165 kilojoules. Fine. So option number 2 will be the correct answer. So moving on to the next one. So we have question number 70, which says that for the reaction, if the concentration of R at equilibrium is doubled, it will cause the equilibrium concentration of Q to change its original value by. So for this reaction, that is P solid is in equilibrium with 2Q gas plus 3R gas. So write the expression of Kc here. So Kc will be equal to concentration of Q to the power 2, because coefficient of Q is equal to 2, multiplied by concentration of R to the power 3, because coefficient of R is 3. And now we will not take the solid because the concentration of solid will not change. So ये हो गया हमारे पास Kc का expression. So now they are saying that concentration of R at equilibrium is doubled. तो चाहे हम concentration change करें but Kc will not change. So Kc क्या रहेगा हमारा? Same. ठीक है? So Q dash we have to find out, and the new concentration of R is doubled. So it will be equal to 2R. So you can equate the first and 2 equation because Kc is same. So ये हो जाएगा Q square into R cube, which is equal to Q dash square. Q dash we have to find out into 8R cube. ठीक है? तो यहाँ से Q dash square divided by Q square, which will be equal to 1 by 8. ठीक है? So यहाँ से new concentration of Q will be equal to 1 by 2 root 2 into initial concentration of Q. So option number 4 will be the correct answer. So moving on to the next one.